So if we go to the in-class demonstration scripts, I find it more interesting if we can all interact with the script while I talk about it. So it's not just me talking on the screen. So you can open this and then you can see all these examples and you can change the slider values so that you can interact with it while I talk. There is sort of a number 1, number 2, 3, and 4. So, and I will take a break in between so that I have some room to have some time to breathe, and also you have some time to ask questions. Right. So that's that, and I'll just dive in quickly to the first, let's say, first session, which is going to be about matching input list. So make sure that you can open this file. And on the top, there is a recap of the things that we've learned before. These are data holders, and we are going to use some of these very simple data holders to illustrate the idea of lists. So the things that we will use today are actually very simple. We will use points. Effectively, they are a 3-dimensional point, so it's consisted by 3 numbers. We will use lines, which are in effect 2 points. Okay, and also we will use this curve as a way to deal with polylines. Okay, so we will basically have from points, lines, and polyline, and things that can go back. Can anyone tell me the component name that can connect between 2 points and create a line? You can type it into the chat room. Great, so it's actually called the line. And from a line to create, and from points to create polyline, does anyone knows the name of that component? What's it called? Exactly, so that's a polyline. So this is rather simple. And it's also good to know the reverse of that. So from the line, if you want to get the 2 endpoints, it's actually called endpoints. So if you have a simple line, or even if it's a polyline or curve, you can get the points back from, so you can jump from the line back to the points. And from a polyline, it's called explode. So that will, if you plug in a polyline in the curve input, you will get the segments out, the lines back out, or the vertices back out. Okay, these are just simple numbers that you kind of have to, that we will use today, and you've probably touched on them before. Integers are, whole numbers. Numbers are numbers with a dot, let's say. And texts are just plain old text that you type normally, okay? One thing that might help, maybe help me present easier, is that I will turn on this thing called draw full names. So you actually see the entire name of the input, okay? So you don't get confused. And I will also turn on this draw fancy wire. It's also nice when you can visualize this. So let's recap on super simple things that we learned before. Even though we have not seen functions this way, but there are different types of functions depending on if you start to see them from the perspective where is this function designed to take 1 input or a list of inputs? And same for the output. So these are very simple functions here. I have 2 of them as example. They take 1 input and create 1 output. So what I mean by 1 input is in one of these input node, it expects 1 number. For example, the addition component expects 1 number on A and 1 number on B, and they add it up, okay? And you get 1 number at the output. So this 1-to-1-to-1 relationship, we can kind of call it 1-to-1 type of functions. These type of concepts that I will, by the way, talk about is on the Grammacio Cola GitHub IO under the teaching materials, under Grasshopper, and under data trees. So if you want to recap later, this is where you can find the information, okay? So these are 1-to-1 relationship functions. For example, this create point functions we've used, you can create a point from 3 numbers. You give it 1 point, 1 point, and 1 point, sorry, a number, and you get 1 point out. So this 1-to-1 relationship is what I kind of call this a 1-to-1 relationship. We have also seen these things in the past where from 1 input, you actually get a list of outputs. For example, the divide curve components that we've used in the past, you give it 1 curve and you actually get a list of points out of this. And we've learned this in the last lecture where these are the indexes numbers of how many points you get. And from here, I have 0 to 12. So we actually have 13 points over here. So these are list outputs. And as you can see, there's a double line right here. You see how the input is all single line. And here is a double line. It indicates that the data that is flowing in this wire has more than one item. Okay, whenever there's more than one item, it's a double line. Okay, so here is another example. You've probably seen, I was talking about it earlier. You have a polyline in here, and in this case, you can see on my left-hand side, this is the green polyline. And when I explode it, I get the segments out, which are the lines, and I also get the vertices out. In this case, I didn't really input, but you know, there's 1, 2, 3, 4, 5, 6, 7, 8 segments. So you would expect 8 segments over here. And can anyone answer me how many vertices I would get? Great, so 9 vertices. So if you hover your thing over here, you actually get 9 locally defined values, and these 9 vertices are the corners, these corners. So great, and as you can see again, it's a double line right here. Okay, so you know that it's a list. The series functions, we've used this 2 lectures ago by giving it one sort of step value and one numerical value. And again, you see this is also a 1 to multiple. The result in this case is a list of numbers, okay? But the important thing that we need to know is that this is a 1 to list type of functions, okay? So let's do a quick rundown and see if you can answer these things. So this is a function that analyzes the length of a given curve. Is this a 1-to-1 or a 1-to-list function? By the way, Leslie, the function to see the double line is the draw fancy wire function. Display, draw fancy wire. Turn this on. You see that's you see I've turned it on by, you see it's kind of have a blue background over there. So that's yeah, you need to turn on that. So yep. So curve length, as someone answered, this is a 1-to-1. You give it one curve and it gives you one value of how long that curve is. This one is called curve midpoint. It gives you the midpoint of a curve. Is it 1-to-1 or is it 1-to-list? Great, it's also 1-to-1. The line function that we talked about, that's a 1-to-1. And how about this endpoint function? You give it one curve, what will happen? So that's the wrong answer. So it's still a 1-to-1 relationship, because you actually get, if you give it one curve as an input, you actually get only one start point and one end point. So don't confuse this. Within one thing, you get only, so I'll just give it as an example. I'll take this polyline again and stick it in here. And then I will just use a yellow panel. You see that I only get one starting point. And that's what I meant by it's still a 1-to-1 relationship. Got it? I'll assume it's cool, okay? So here I have a function that's called control points. If you give it a curve, it actually returns you all the control points. So is this a 1-to-1 or a 1-to-list function? 1-to-list, correct. I also saw someone saying that someone misses the curve middle component. This actually happened to one of our tutors as well. So I don't know why, but some people just do not have the curve middle function for no reason. I'm using Grasshopper version 1.0.7, same as my colleague, and he doesn't have that. So I don't know why, but maybe you have to reinstall your whole installation. But anyways, so that's the point. If you give it one control, one curve here, in this particular output, and only this, well, actually also the weights and not the knots, but in this particular output, it's a 1-to-multiple output, okay? Not necessarily the others, okay? So this 1-to-list or 1-to-1 relationship is very specific to one particular input and one particular output. So in this case, it's obvious if you give it a curve. I'll move again that polyline over here. I get the list of control points, and it's effectively the same as the corners of the polyline, because polylines are just straight segments. And particularly for this, it's a 1-to-list. Let's take a look at weights. So weights are also 1 to list. All the weights are 1. And all the nots are also have a number. So these are all one-to-many functions. This is not always true, okay? And some of the components have some outputs that are list and some are single item output. So, okay, we're cool with that. So we have one-to-one, one-to-list, and of course, we also have something that are list to one, okay? So I'll give you a simple example. For example, the polyline that you will need to use in your assignment. So, you know, smart students would, you know, immediately copy this and put it to the other assignment file. But anyways, you understand that if you give it a list of points, you will create one polyline. And the polyline goes through all these points. So I think the example is over here. If I highlight that, I get all the points. And if you give this polyline function all the points, it gets one curve output, okay? So this is kind of easy to understand, yeah? You get a list of points and you get one polyline out. I mean, it's hard to really, you know, further elaborate. But one thing notice here, this particular, let's say input is expecting you to tell the function whether you want a closed polyline or an open polyline. And in fact, if you hover through, you see the logo. It's a Boolean logo, the black hexagon thing. And if you, and in this particular relationship, it's expecting only one input because, hey, I have a list of points. Do you want this polyline closed or not closed? So you really are expecting one input. It doesn't make sense to say, hey, I want to create one polyline and I want it closed and also open. It doesn't make sense. So in this particular case, this one to list relationship is actually expecting one. If you turn this all true, you see the polyline is being a closed polyline. And if it's, you know, it makes sense, right? So this one to list function relationship or list to one relationship is very much independent per input and per output. And in this case, the first one is a list and the second one is a single item. And the output is also a single item, okay? And this relationship can get messy, but it's going to clarify once we get, you know, towards later, okay? So there's also another two examples of this list to single item relationship. One that is we also learned 2 weeks ago, 3 weeks ago, is you can actually ask Grasshopper how long is a list. Basically, these functions will try to tell you how long that list is. So in this case, there is 5 items in there, and you would expect the, you know, you would be able to ask how many items are there. So in this case, it returns only one single value because that's number 5 that describes how many items in that list. So for every list as an input, you only get one answer. Okay, that I hope it makes sense as well. Another example is this text join function. You can join multiple text segments. We will actually see this again in a later lecture where I can join different numerical values that are automatically generated with a little, in this case, I use a dot. You can use another thing, for example, a comma, and they join it with a comma. And in this case, it's joined into one single value. You know. So the relationship between the first input text is a list, and the output is a single item. Yeah, so these are just different examples. And of course, last but not really list is that we have one-to-one, one-to-list, and list-to-one. So of course, the last one we will talk about is list-to-list. It's not exactly, I'm just pulling out examples of these things, and they're not super important as to remembering which one is which one. And I'm just showing you these things as an example. And the list-to-list example, there are not that many, let's say. But this one is a particular common one, which is to sort some values. So the first function generates a list of random values. And by the name of the fact that I call it a list of random values, you know that this is probably a one-to-list type of function. Okay? But then the second one sorts this list. So it sorts it by the value, from smallest value to the largest value. So this particular function, you can see that the input is a double line and the output is a double line, and that's expecting kind of a list in, list out thing. Yeah, in fact, the list is not really modified, but only rearranged in this particular function. But Anyways, the thing about this is that it's not necessary for you to remember which one is which one. Of course, the more you use Grasshopper, you will by nature know that a polyline is expecting a list of points and generating one polyline. But the more important thing is to be able to help yourself. So if you face a new function, for example, let's say this random function is new to you, okay, and you don't know whether it's expecting a list of it as an input or output, all you need to do is to hover your mouse and get a tooltip at the input or output number. So not hover in the middle. In the middle, you actually see the name, but you hover at the input. For example, in this number, it's the logo is the number 7, so you know that it's an integer, and it says number. Okay. If it doesn't say anything else, it's expecting one single item. For the output, where it's called random as list, then it's obvious. Okay. This is going to give you a list. Now, this is not a must. For example, it's not a must that it gives you a list. In what scenario? Try and use your brain a little bit. In what scenario this will actually give me not a list but a single item? Try to think a little bit. In what scenario that it would not give me 10 items, but only one single item? Yeah, so someone, Lucas answered. So if the number input is 1, okay, it will actually collapse into just one single item. So let's give it a try. If we slide this all the way back to 1, notice how the double line changes into a single line, okay? And this is a behavior that causes a lot of, let's say, confusion between students. Why does this suddenly becomes a one-to-one relationship? So just be aware. It's really outputting you a list. It's just that this list has only one item. We'll get back to this problem later, but just be aware that there are scenarios where this suddenly becomes one single item, okay? So don't, be aware. Next, I will talk about the interesting concept of list matching. It's not a professional term, but a lot of people describe this, let's say, operation this way, is that you need to match your list. So I'll use a very simple example. It's like super trivial example of the addition command, which adds 2 numbers. I put it in gray box because you've seen it up there already. It expects one number, second number, and creates one number as output. So it's a one-to-one-to-one. No, it's a one-to-one relationship, input-output functions. And we've seen that with one input, you get one output, multiple input. So if you give a list of numbers to this addition, instead of one item, so in this case, I am giving A input a list of functions, and B input only one. Okay, so it makes sense. Okay, think about it in a let's say a human computer. People can compute things, and if you ask somebody to say, hey, can you add this list of number with this for me? And that person would reasonably make sense and say, okay, so what I guess you mean is that you add the first item, number 1, with this number, and you repeat this effort for all the items in the list, okay? So as you can see in the output, all of the input item in the first list A is being added with 100, okay? Again, the first number here are the index values from 0 to 4, and it's the same for the output indexes. It's from 0 to 4, and this is a type of matching where a single item is matched against a whole list. And for this, the whole item is going to be repeated, and this function is going to repeat it for every item in the list, okay? In speaking about the same thing in a different way, some people don't think in this way, but think of it as a automation perspective. So in the past, with just one-to-one relationship, it is one item being added together. And now I want to automate the action of adding many things together at the same time, in this case, 5 numbers. So by using the list, I can repeat this function as many times as the list are to do this as many, to loop through this and do this as many times as is necessary. So you can see there's also a way to repeat this function many times. Okay, so I hope this is clear. What happens when the second list has two elements? Does it add them? Wait for me. We slide this to the right-hand side a little bit. There's case number 2, okay? And it's not yet getting to your question. Case number 3 is actually your question, but I'll just logically keep going. So this is case number 2, where there is 2 lists of inputs, both in A and B. Okay, I like those curious questions because that's the ultimate difficulty. Again, if we tell someone who can add things together, add these 2 lists together, okay? That person would almost, literally make sense by saying, okay, you have 5 items here, you have 5 items there. You probably mean by adding the first item with the first item, the second item with the second item. And as you can see in the result, that's what's happening in Grasshopper. So if A and B, okay, let me repeat it in a different way. Yeah, it's the same thing. If list A and list B as an input have the same amount of items, while this function is expecting only one A and one B as an item, not a list, this function will be repeated for every pairs that are matched up. So again, this is a list matching where one item is matched with another item. Yeah, and the resulting thing is, you can see, it's literally as if I put a plus sign right at where my cursor is and where I put an equal sign and repeat that plus sign again and again and again and again. Okay, so without messing up my thing. So I hope that's easily understandable. And case 3 is the questions that Powell asked. So what if this 2 list doesn't have the same number? So in this case, the first list has 5 and the second list has 3. And you can see that the output becomes a bit weird. Okay, the last item that happens in this list, which is the number 30, okay, will be repeated as many times as the other list have. So it's as if you tell a rather dumb person to add these 2 lists together, and this dumb person proceed with the first item. Okay, 1 add 10 plus 10, you get 11, and 2 plus 20, you get 22, 3 plus 30, you get 33, 4 plus, wait, there is nothing here. I'm just going to take the last value that I saw right here and do the same thing. So that's what's happening here. Okay, so it's a very rare scenario that we will use this. The reason why I'm introducing this is because it's very likely that you're making a mistake and you are doing this to your functions. Okay, so just be aware that this might come up when you make a mistake, and or maybe you can use this as intended. Okay, so from the last exercise, I actually saw a very nice example of the coronavirus being around a sort of a hypothetical country border. And I find that super interesting. In fact, this student asked me how to do this in class. And I remember there were more than one person doing this, but I remember it's a very cute looking coronavirus drawing that's being done in Rhino. So the student draw this thing in Rhino and even used polar array to make these sort of, I don't know what, the antigen on the outside of the virus to be polar arrayed around the thing. And then the student, right click on a curve component and then set multiple curve and then selected everything in Rhino. And since we've learned the idea of divide curve last time, and we also learned the idea of orient, this student draw a hypothetical country border and divided this curve so that you get a list of points, and attempts to use Grasshopper to spread this virus everywhere. Luckily, that student did not succeed. The virus is broken apart. The situation here, now you might now understand, is because that after divide curve component, you get a list of points. And then this coronavirus have also a list of components, in this case 12 components, because in Rhino, you can draw multiple things and you can group them together, but the concept of grouping does not exist in Grasshopper. You cannot group them and say they are one single thing. If you have 2 curves, and in this case I have 12 curves that the coronavirus has, it's 12 items, okay? And if you've divided your curve and get some number of items, and this can obviously have more items, okay? What happens is that the list matching happens right at the orient function. The orient function normally takes in one geometry, one source plane, and one target plane. So it's a 1, 1, 1. And the geometry output is also 1. So it's expecting one thing. And when you give it a list as an input, in this case, I have 12 corona parts and 20 targets. What happens is that each part of the coronavirus is being oriented to one target. And until the list is running out, the last item is being repeated. Okay, so I'm guessing it's these little bits that's being repeated again and again after it's running out. These are the sort of early items, and that's why it's broken apart. Okay, so it's the same scenario as the case 3 above. That's the sort of mistake that many people will see pretty often, is that this list matching is not being done properly. Okay, I'm reaching the break. So I'll look at what you guys typed in terms of questions, and let's take a 1 or 2 minute break for me to at least catch a breath. Let's continue. So let's say, how do you draw these light triangles behind to group elements? Ah, yeah, you just group. You select all of them and press Control G or Command G. Or the less fancy way is to press, I think, edit and group. And there are at least 3 or 4 different ways to do exactly the same thing in Grasshopper. You can press the middle mouse button and press group. You can press your space bar. Oh, no, you can't do this. Okay. All right, so let's come back. So I hope that this is kind of clear. The list matching is extremely important. And then the next, so I guess the first step is I make you understand why we need to do the list matching. And the second step is doing it, okay? So I'll give you an example, and the example is a rather simple one. If we can construct a single point using 3 values, how do we construct a list of points with just one component? Of course, the dumb way is to say, hey, I can, make a copy of the entire thing, and then I have one more point, and then make a copy of the thing, and then I have another point, and make another copy. And students do this a lot, If you need 5 points, you make 5 copies, and then you adjust them, super tediously. Everyone is slightly different. Okay, don't do this. This is kind of the dumb way. The reason why we use computer is not to do things, the manual way. So of course, there's a way to automate this, and that's what you can try together with me, is by combining a list of numbers as an input to the construct points. So we've learned series as a way to generate a list of numbers, and we've also learned that we can plug this into one of these components coordinates, let's say, in the construct points. So let's give it a try. Instead of getting an x coordinates with only one item, and you can actually find this point right here if you, it's right here. If you plug in a list of values, and in this case, I'm replacing the x coordinates, I'm getting a list of points right here. Okay. So a little task for you to do is to say, think about it. Right here, you have a list of points, and they go horizontally from left to right. What if I actually want a diagonal one? What do we do? Can someone answer from the chat? If I want them to be diagonal, what does diagonal really mean? Let's say, what does horizontally repeating means? Horizontally repeating means that the x value is changing in every repeat of this command. So we have 4 items in here, and it's being repeated 4 times. Yep, so someone got an answer, which is that if we also plug this guy into the y component, okay, then we actually change both the x and the y, and we get a diagonal line happening here. Okay, so that's easy to understand, yeah? And if you didn't get the solution, there is a green area which shows the 2 solutions that I've just did. So you can play with that. And the next thing that we will try is that, no, the previous thing we've tried is trying to put list where it's expecting 1 item. Okay, and the output becomes a list. So let's just recap a little bit. So Construct points expect one item, and since we've given it a list, the output, which usually gives you one item, now gives you a list, okay? So what happens if we give this 1 to n function, instead of giving a 1 as an input, we give it a list as an input, what happens to the n? So that's the meat that I'm getting to in this lecture, which is that instead of getting one list, you get multiple lists, or again, the fancy way of saying it, a list of lists. So here is an example, and if you look at it on this side, I have a list of curve inputs, 3 curve in this case. And normally, this divided curve gives me a list of points. But in this case, because I am feeding a list into the curve, which expects 1, instead of this 1, I'm giving it a list. And what happens is that n becomes n of n. So you can look at the output. The list of points that we generated here is a list on every curve, and it's effectively 3 lists of points. So if you look at the output, you can see that there's 3 lists, and you can see the list index value in every list start counting from 0 to number 6. So there's 7 items in there. And you can even see that on this sort of slightly darker area, that there is a list, the name for each list, okay? This one is called 00, this one is called 01, and this one is called 02. And this, in the context of Grasshopper, we call list of list a tree. And these lists within a tree, we call it a branch. And these names, we sometimes call it a branch name, okay? So this is what happens when you start getting a tree. Now, again, if you're slightly smart, you already start getting the fact that, this is probably the entry point to your first assignment, dividing your curves automatically, yeah? And, the trick is to connect them the right way, from 0 to 0 to 0. We'll get to that. But before that, we also should notice that in case there is a multiple list in the data flowing, the double line becomes a dotted double line. So you see, if I don't highlight this, it's a double line input on this side, and it's a dotted double line on the output, okay? So just a recap, well, it's done, it's fine. You guys should be more attentive than this. Okay, so I think this is another example. This is the concept of a matched list can also happen when for these type of 1 to n components. So it's very similar to the example above, and this is the example in this case, where I have, again, a list of inputs, 3 curves. And instead of dividing it by the same amount, I also give it a different value for dividing. And in this case, it's 5, 10, 20, and then you get 5 divided segments in the first one, and then they can be different. So this matching concept can also be applied here. Okay. There are many scenarios where we might want this behavior. For example, let's say the divided points in this example from the previous curve division. I would like to connect them to a different point right here. So this is a matched list. So in normal sense, the line command, which is expecting a 1 to 1 to 1 relationship. And if I match it with a tree scenario, let's expand this and look at it for a moment. What happens is that this line function will be repeated first per tree branch, and then per the item in it. So we know already what happens in the one list scenario. Basically, in a one list scenario, all of these items is repeated with the single item, which is what this is happening in one of these branch right now on the Rhino side. Okay, and in the case when there are multiple lists, this is going to be separately repeated for every list, so that the first item here, which is the dot right here, this dot, is going to be connected with the first list, the second item with the second list, and the last item with the last list. And therefore, we can do these type of operations. And this is actually a very similar data structure as the one that you would do for the triangle exercise task 2. Okay. Now, normal points do not normally come in a tree structure like this, okay? If you, sort of right-click and say set multiple points, you normally get a flat list, not in a nice tree pattern like what I have over here. The reason why I can have this is because I kind of hacked it until it works and it's saved into this particular point thing. But normally, you don't get it. I'll give you an example. So let's say I've drawn 3 points that I was expecting it to be connected to the three list of points, and I right-click and I say set multiple points. No, 6. And what I get is a flat list. And you can also see that in here, it doesn't work. All the lines are messed up. So that's is the first sort of tree manipulation function that you will learn, which is called graft, G-R-A-F-T, or draft, or graft, or whatever you like to call it, okay? By grafting this, it turns a flat list into a tree, okay? And there are multiple ways to do this, okay? This is an example, and it's here, okay? It's the same example where I divided the number of curves into points, and I want this list of points to be connected. So if you look at the first input, the first script, it's all a mess because it was not in the right matching thing. You can see that there is no tree that matches with the 3 trees over here. Okay, so that's not the way to do it. The more proper way to do it is the middle one. Is you put it into a graphed tree component. What this does is that it changes this flat list from what it looks like here to this. And by doing this, it can be matched properly, okay? There is a shortcut to do this, which is what I've been doing here. You can also put right-click on an input or output and click graft right here. And that you will also get a similar result. Okay, so now knowing that you can graft things, we can already fix the corona example. Here is a magic portal that if you double click, it brings you back to the coronavirus example. So if we go back up there to the coronavirus example, what we could have done to fix this is to graft this, okay? And it's easier to do than to explain because the thing that needed to explain is rather complicated. Basically, we want to move all of the corona parts to every one of the target, okay? And what we wanted to do is that we want to make every target a separate tree. So what I will do, I will right-click on these points, or I can right-click on the target. Either one of them will do, and graft that, okay? Now that you see the coronavirus is moved properly, now I will explain why it works, okay? It takes a while to understand this, so if you don't get it the first time, it's fine. Rewatch the video. What happens is that by grafting this, I made every target a separate tree. And remember that the repeating of the function happens both at the tree level and also at the list level. So what happens is that for every target is a tree, it will perform this function once and matching it with the first list. So you can see that the first list, conceptually understand it, matching with the first list. And because there is only one item matched with 12 items, all 12 items will be moved to the same target location, which is probably one of these corona. All 12 parts are moved to one single location. And this function is going to repeat with the next list. And the same behavior happens. This list have no friend. There's no matching list on this. Grasshopper will take the last appearing list, which is again the same list, and do the same operation again. So this repeats, and basically we've successfully executed this evil plan. Good. And now I need a little break as well. We're also running out of time a little bit, so it's already 4:04. And it's likely that I will need to get to the assignment tips. Okay, I don't really have to give you tips. I mean, come on. The first one is so easy to do. There's only 4 components, and you know you need to kind of explode it. You need to kind of divide it and kind of join a polyline at the end. So I've described the 3 components. There's only one that's missing, and I'm getting to this right here. All right, so give me a minute. And welcome questions, yes. So this is section number, let's say 3, okay? The things that I want to quickly go through here is that the idea of list management that you might know some of it already, for example, list item was the one that was used in the last assignment, can also be operated on a tree as well. What will happen is that you know, in this example, you can get an item, in this case, by using the list item component, and you get one item out. But it also works on trees. So for example, you have a tree of points in here, and the list item will be repeated for every list. So effectively, if I say get item 0, the list item component will be repeated for every branch of the input, okay? There are 2 ways to understand this, okay? The first way is to say, this component expects a list, and now that I'm giving multiple lists, it's repeating itself for every list that is happening. And what happens to this list is that it grabs the first item in each list. The output will be like this. So the output will maintain the tree structure, and that only one item is being outputted. That's probably the easier way to understand this. The less intuitive way, or perhaps more mathematical way to understand this, is instead of an n-to-1 relationship, okay, we've given it an n of n as an input, so that the result is, instead of 1, it's an n. So choose the way how you like to understand it. And other functions that used to operate on a list can work on trees. For example, split list, you can split a list into 2 lists, okay, A and B. And you can work on this on a tree. For every list inside this tree, it will be split into 2 lists. So you see the output, it has maintained the tree structure. And on the top, it has 3 items on every list, and on the bottom has only 2. So simple idea, yeah? Things that used to work on a list works on a tree, and it works repeatedly for every branch, yeah? Okay, so here is a function that we have not talked, I think we have not talked about in the previous lecture, called dispatch. And this is a list function. And the reason why I'm explaining to this is because we can use this function in an example that I will not explain because I'm running out of time, below, that can easily create a brick wall pattern that we will use in later classes. So you can go through this yourself later, but I will explain what this function do, okay? This function effectively split a list into 2, but by dispatching them in an A-B pattern. So the first item goes to the first list, and then to the next one, to the next list, and then back to the first list and the second list. And therefore, you can see that 0, 2, 4, 6 went to the first list, and the other one went to the second list. Okay? And a dispatch, you can give it a sort of custom input, but if you don't change this, it's A-B, A-B, A-B pattern. And a dispatch has a counter antidote. It's the weave. So weave does the opposite. It takes 2 lists, and then it weaves it back with a pattern. So the default pattern, again, is the A-B pattern. So you can weave it back in a way like this. Super fancy. How do we use this? You will see that in the example below when we talk about the brick wall. And this weaving function is taking multiple lists. It's very different from the other one that you might have used before. It's called merge. Okay? Merge, take the list and put the items behind. Okay? So notice the difference between these 2. Huh? One is that it weaves it back properly with the A-B pattern, and I'm getting the 1, 2, 3, 4 sequence back correctly. The other one, I'm putting list number 1 on top of list number 2. So it's effectively just, you see 0, 2, 4, 6, 8. It finished the first list, and then it moved to the second list. 1, 3, 5, 6, 7, 9. Yep. So there is this difference. And let's say these are very commonly used methods to create patterns. For example, a brick wall, which has an A-B pattern, yeah? like the one shown here. No, you can. So, yeah. So both Achilles was pointing that there's a very fancy advanced thing. So, for fancy students who get everything what I've said, if you're already confused, don't listen right now because it's going to get you more confusing. You can actually merge multiple lists or weave multiple lists. If you zoom in and zoom in until there is a big plus sign that happens right here, you can actually have 3 lists or even more and more. And as you press more, you can have a pattern that is fancy enough to say, okay, it's 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, and it's going to repeat. And this zoomable user interface, I think that's how Grasshopper is calling it. You can do this with certain components too. So you can merge multiple lists. Of course, if you don't know this, you can also use an other merge to, merge it like this. It's fine. Okay, it's just a fancy thing. Nice to know. Okay, so that's getting to the last part of the bit that you will need for your assignment. And before I need to introduce this, I will introduce a very special function, which is a 1 to 3 function. So it's not just a 1 to n, but directly a 1 to 3 function. Not 1, 2, 3. Kind of reminds me of my Singapore time. It's the rectangular component. So if we look at the example, it's here. The points are here. You literally give it a starting point and then say how many rows and items you want and the spacing in between. And it gives you this, you see, this is the spacing adjustment. This is the how many items adjustment. And you immediately get a list of a tree of points neatly arranged into a tree for you. You can see that if I plug it into the point list component, it draws the 0, 1, 2, 3, 4 for me, and it draws it starting from 0 multiple times because this point list component, if you see it again the way, it's expecting one list, and since we've given it multiple lists, it's repeating. And every time it repeats itself, it starts counting from 0 again. So yeah, and this particular tree of points is quite special. It has the same amount of items in each branch. So there is 5 points from 0 to 4 in each of these 3 branches. And these particular types of trees, some people like to call it a rectangular array. An array is like a list and a list of lists where every where every branch has the same amount of items, and it's rectangular, okay? And this particular type of array, there is a very fancy thing you can do with it, which is called the flip matrix function. The flip matrix function, you need to scroll down a little bit here, is right here. So again, I have the points. And if I see these points with the point list components, you can see that it's actually going upward, 0, 1, 2, 3, 4. But after the flip matrix component, the direction flipped. Instead of 9 branch with 5 items, I have now 5 branch of 9 items. Let that settle a little bit. Takes a while. And if you see this with a parameter viewer, which, sorry, I have not introduced, which you can get from here. This is a parameter viewer, this gray box. You can actually see the tree structure. So if you plug it in there, you see how many branch, their names, and how many items. And if you double click on this guy, you actually see the tree structure. It's not super important, but it's nice to know that how many branch you have and how many items are there. Yeah. Just a quick note, if you pass a non-rectangular function to this flip matrix, it will complain the hell out of it, and it will go red. You can't do this, okay? So it has to be a rectangular array before you can flip. And now this is what I meant by you can connect things in a different way, okay? We'll get to that. We've talked about the graphed function earlier. There is also an antidote of the graphed function, which is called the flatten function. So this example on my left is if I take these points and I put it into a flatten. So that one actually removes all the branch. So we have flip matrix and we have this flatten tree. It flattens all the branch into one single branch and packs all the items one after the other according to their original appearance. So as you can see in this point list, it's 0, 1, 2, 3, 4, and then it continues with 5. And if I draw a polyline, the polyline actually continues because it's as if it's a single continuous list. Yeah. So that's all basically. Until the graphed tree, we've talked about that already. Both the graphed tree and the flattened tree, you can do this by right click. In fact, there are other things that you can do by right click. You can reverse the list, you can flatten, you can graph. Reverse is as it says, you know, it reverse the direction. Yeah. In this case, if I press reverse, you can see that the 0 goes from the other side. Yeah. But that's rarely used, let's say. But graphed and flatten is very common. Simplify is even less, so it's fine. So this is basically the part where I will not go through with you, 0.5 brick pattern. And here I'm using the same thing that we've learned, the rectangular function, the flip matrix function, and that will allow you to draw a brick wall that has no bonding pattern, okay, like this, just a rectangular grid of bricks. And the second example shows you that you can use the dispatch function, in this case here, to make one that is bigger and one that is smaller. And conceptually, if you make the smaller one so small that it just goes away, and make the big one big enough that it actually becomes a brick-like object, then you can apply this in another direction as well by using the flip matrix again. So this is the example at the bottom, and you can check it out yourself. Okay, and you can create this brick wall pattern by having an AB pattern.